Thank you. I also want to thank the organizers for including our paper on the program. I should just mention at the beginning that this is joint work with my co-authors, Luigi Zingales at the University of Chicago and Adair Morse at Berkeley. I teach a program in Toronto for directors of public corporations. And one of the first things whenever I start the program, some of the directors are like, why do we need to do all this governance stuff? And it's a fair question. And so to that question, you kind of want to have an answer that says, well, okay, there is an underlying, the agency costs are sizable in corporations, or you want to know how sizable they are. And it's actually not a question only for boards, it's also a question for regulators. If you're thinking about whether you should introduce some interventions to try to address agency problems, you really need to know, how do you do the cost-benefit analysis? That cost-benefit analysis, you need to have a sense of what's the size of the problem, and you have to know what's the cost that you're introducing associated with your intervention. So it's a very fair question. It's actually a difficult question, and I'm going to suggest that there really aren't settled answers to this question. And it's an important question. It's important because if fraud, for example, is not a very big problem, then it's very unlikely that any kind of interventions that you could introduce would be helpful. Because if it's a small problem and there are costs associated with interventions and we know those costs, then it's not going to be worthwhile. On the other hand, if the problem is large, then at least that's a first step to saying maybe we should introduce some interventions, and then you have to ask yourself, do those interventions actually help solve the problem? So I do think this is actually an important problem that we need to get our arms around. But an important reason why there isn't a settled answer to this is it's actually not enough to look at the scope of actual detected frauds, which is actually what we know something about. And the reason why is, here's a little cute graphic, is what we call the iceberg problem. And the iceberg problem is that we observe detected frauds, we observe the tip of the iceberg. What we don't know is what lies beneath the surface. And if we want to actually get the sense of the scope of the fraud problem within publicly traded corporations, we'd actually like to know the whole scope of the problem. That is difficult to do. It's in some sense difficult to almost an unknowable problem because it's what we don't observe. And so the contribution of our paper, if you see that there's a contribution, lies in trying to tackle this iceberg problem. And we're going to try to, in tackling this iceberg problem, arrive at a new estimate of the pervasiveness of corporate fraud. And then we're going to go on to assess what is the cost of fraud. And then with that in hand, you then have some benchmark against which to compare the costs of regulatory interventions. At least it gives you a chance. And the way that we're going to do this just really simply is in an earlier paper with Luigi and Adair, we looked at who blows the whistle on corporate frauds. We put together a sample of corporate frauds based on some security class actions. We're going to use that same database, and then we're going to try to take advantage of two experiments to try to get a sense of this iceberg. One experiment utilizes the fact of Arthur Andersen's sudden and unexpected demise, and thinking about that as an example of a forced auditor turnover. And since new auditors have incentives to reveal the problems of their prior ones here, we're all of a sudden going to see frauds that weren't otherwise revealed. That's going to be one shock that's going to give us a sense about the size of that iceberg. It's a non-trivial shock because that Andersen was the auditor for about 1/5 of all publicly traded corporations. Secondly, we're going to try to take advantage of our prior work and take advantage of situations in which basically we can run some regressions where we know, for example, that if firms with more analysts, there's less frauds likely to be committed, and kind of do a synthetic experiment where if we use our coefficient estimates and look at firms as if they were to have lots of analysts, how many frauds would be revealed under those scenarios. So through those two experiments, we're going to come up with different ways of getting an assessment of what this iceberg is, and then with that in hand, we're going to take a look at the costs of fraud. So that's basically boiled down here. There's a couple ways of viewing papers. This one is kind of, I think it's an important problem. It's not going to be the most technical paper you're ever going to see by far, but we try to apply some judgment to the choices that we've made. And I'm really delighted with the discussant who's an expert in this area and is going to give us some further suggestions on how we can refine our estimates. Let me just start off here. Whenever you talk about fraud, you have to say, well, what are you using as your definition of fraud? How do you think about fraud? And there's lots of different databases out there to try to do this. One is to take a look at firms in which there were financial restatements. Another one is to take a look at firms in which they're accounting and auditing enforcement releases. They're both signs of problems because firms had to take actions consequent to their financials. These are focusing on financial misrepresentations. There are also firms where there were some security class actions that are filed. That would include financial misrepresentations, and they can also include other frauds. There are a bunch of different samples out there. All of them have challenges for getting a real sense of actually what we're worried about as sort of true frauds. And my discussant with his co-authors has done a great paper on reviewing all the challenges associated with these databases here. I'm just going to highlight two that we focus on. One problem is there's a danger that they might be over-inclusive. That is, they would include, in addition to real frauds, let's think of Enron, Adelphia, WorldCom, things of that sort, they might include a bunch of frivolous cases, for example, that class action lawyers are trying to make some money. Another problem is they might be overly restrictive. If you rely on the fraud detection on someone that has a limited budget or is subject to some sort of political incentives, they may not have an incentive to go after some firms. So these are problems with all the databases, and you have to kind of see where it kind of adds up. And so in the end, we make a choice that we're going to focus on the Stanford Security Class Action database and applying the filters that we previously employed in our earlier paper here. There is an advantage to this database. One advantage is it's likely we restrict our sample to all large firms. They had to have more than $750 million in assets before a fraud started. And the reason we want to do that is we think in those large firms, the the attorneys have a strong incentive to file a class action if there's any inkling of some form of wrongdoing. Right? So this is not going to suffer from the problem that real frauds are not brought up in the first place. The problem with security class actions is, well, they're going after money, and there's probably too many cases that they go after, a lot of them which are scurrilous. And here we take advantage of some aspects. First, a large number of these suits are dismissed by the courts, and so we don't include those. We take advantage of a legal literature that has used a dollar settlement amount as some indication of level of severity, and we impose a couple of other filters. And so we suggest that this sample of 210 frauds of the 1996 to 2004 period captures substantially all of the frauds in this sample of large firms. And that's what we're going to do. I just want to note that about 2/3 of the sample focus on financial misrepresentations, which has been the focus of much of the fraud literature, and about 1/3 of them are kind of lying about other things, about the future. When you make misstatements, for example, a biotech firm lying about what's going on in its trials for its drugs or something of that sort, which would have a material impact on share prices as well. So how pervasive is fraud? Looking at detected frauds just gives you a picture over time of what we see in our data from 1996 through 2004. This is adjusted. I'm going to ignore the adjustment for now. What we sort of see is around 1.3% of firms per year start a fraud. And since a fraud lasts for close to 2 years on average, that means that the number of firms in which there's an ongoing fraud at any point in time is going to be bigger than 1.3%. And over this period between 1996 to 2004, that's what that line across the top suggests. It's about 4% of firms of more than $750 million in assets that are publicly traded. There's an ongoing fraud using this definition of fraud. And what you see is there's a bunch of time series variation, and we think it's actually important when we're taking a look at some baseline level of fraud that you take a look over a reasonably long time period to capture both when there's lots of frauds being started and detected and when there are not. And that's, so what I wanted you to take away from that picture is that if you think, is fraud a big deal or not, even from detected frauds, you should get your attention. If you accept these are as detected frauds, you would say, look, 1.3% per year, about 4% on average over a cycle. That seems like a large number here, and we're going to use this baseline number later. Of course, if I was to use a different fraud sample, I would have a different baseline number. Some of the things that we're going to talk about later, which is the detection likelihood, could be applied to other samples as well, if you want to use a different baseline of fraud. But we're going to use this one because we're going to be consistent throughout our database. But again, if you wanted to say you wanted to take a look at restatements or AERs or something else, you could start with a different baseline. Let me just sort of get to the nub of the problem and why there is an iceberg problem. What we observe is the joint probability of a fraud, someone engaging in a fraud, and they're caught. What we're really interested in is the likelihood of the unconditional likelihood of a fraud starting, of someone engaging in fraud. And the relationship between those two numbers is if we knew the detection likelihood of the numbers of frauds that you start, that you actually get caught, which is the denominator up here, then we'd be well on our way to be able to, from observables, identify the unconditional probability of starting a fraud. So if we knew the detection likelihood, and then when we observe the actual detected frauds, we could back out what the unconditional likelihood of starting a fraud. And so the idea, our identification assumption is that if we could identify situations in which the detection likelihood goes close to 1, we can sort of back out this number. So that's what we're after, is trying to identify some circumstances where there's a shock to the detection likelihood. Either an actual shock, which is the Arthur Andersen experiment, or a synthetic shock that we create by taking advantage of our coefficient estimates. So Arthur Andersen, the way we like to think about Arthur Andersen is it was a forced auditor switch. All of a sudden, Arthur Andersen was indicted. It wound up shop. All of the publicly traded firms had to get a new auditor. When they got a new auditor, the new auditor took a look at what was going on in the firm, and some of them brought some frauds to light here. There is strong incentives when you have a flip of auditor to not make the other person's problems your problems here. In order for this to try to get we're assuming that there's a couple of assumptions that are important for this Arthur Andersen experiment to provide a good experiment to identify this detection likelihood. The first assumption, I just want to be clear about the assumptions, and this one may be controversial, although in the end I'm actually comfortable with this assumption, is the assumption that the Arthur Andersen clients prior to the Andersen being demised were no different than the clients of other auditing firms. Right, so the idea, again, this is a forced auditor switch. I'm not saying Andersen was worse at all than any of the other clienting firms. It's just that all of a sudden there was this shock that was imposed upon them here. Now that might be surprising, and it was a little bit, I wasn't comfortable when I first looked at this paper here that, no, Andersen was worse, right? They were not doing their job, because we know in the case of Enron. But a couple things I just want to draw to your attention here. There's a large number of papers, although clearly not all, in the accounting literature that sort of come to the same conclusion that's necessary for us to go forward here, is that the clients, there were no differences on observables between the clients of Arthur Andersen and non-Andersen clients prior to the firm being wound up. Also, interestingly, the concern of the government with Andersen was not for all of their clients. It was a specific case of Enron and obstruction of justice, which was overturned upon appeal. So there's a lot of evidence that would suggest to point in the direction that there are no differences. We were interested in sort of running our own tests to see if we could see any observable differences between Andersen and non-Andersen clients prior to Andersen being wound up. And what we took a look at is saying, look, one indicator of manipulation is something that Benish has put together, and it's a probability of manipulation score. And let's see if there are any differences between Andersen clients and non-Andersen clients based upon that. This is just another sort of test if there's a difference. So just give you some summary statistics up front on the panel A and the univariate statistics here. This prob M score, which is this Benish probability of manipulation based upon observables in their financial statements, and then we just compare the AA firms versus non-AA firms, or AA firms versus big 5 non-AA firms, and we find no differences. Now that's not convincing in and of itself. We'd have to control for a bunch of other characteristics. There might be different industries in which the firms are involved in. There might be a number of other differences in terms of firm characteristics. So we ran an OLS regression and a median regression comparing Andersen against all other firms or Andersen against other big 5 firms, and again we found no difference. So we're going to move forward with the assumption, and it's a necessary part, that Andersen clients were no different than non-Andersen clients, which allows this shock to allow us to infer the detection likelihood. The second assumption is that the probability of caught for financial fraud, if you're an Andersen client, post the forced turnover goes to 1. Now we think this is a conservative assumption. We think there are incentives to clean house, to show there are other, these things can also be diminished. For example, if the same auditor used to be the Andersen auditor, he's hired by another big firm and they brings the clients with them, they may not have the same incentives. So it is probably a conservative assumption, but we're going to kind of go with the assumption that all of a sudden the incentives to bring all those fraud slights goes to 1. And then what we need to do then to get the sense of this likelihood is compare those firms that were Andersen clients, take a look what happens post-Andersen demise in terms of auditors detecting the fraud, and compare that to a bunch of other firms that never had Andersen as a client and the likelihood of an auditor bringing out a fraud with them. So comparing those two numbers, so these are, let's say, a PwC clients, the likelihood of auditors bringing concerns about fraud with them, compare that to former Andersen clients, auditors bringing out concerns about them. So it's the ratio of these two numbers that we're going to take a look at. And what that really comes around to, in the non-Andersen firms, the likelihood of an auditor bringing a fraud to light is a low 0.6%. And in the likelihood of a former Andersen firm that's now being audited by someone else, it's close to 2%. So it's almost about 4 times more likely that an auditor will bring a fraud to light in the former Andersen clients relative to ones that were not Andersen clients. And that's kind of our core. So we take this detection likelihood, we take this baseline level of frauds, and we multiply it times this number. Now this is not the only number you could look at, because we're just taking a look at the sample of frauds in our sample. One could use other samples, for example, accounting and auditing enforcement releases. And using that sample, we get the ratio of those two numbers is about 0.57, which means that there is something beneath the surface, but for those looking at all AARs, it's not quite as large. We like to focus on our number because we think that's the clean Andersen shock. It was a shock to auditors. Auditors really had to clean house. They really did their job, and when they really do their job, they reveal 4 times more frauds. That's, we think, is actually a kind of a nice experiment. If we take a look at all AAERs, we're not really focusing on auditors specifically. So, again, what I want you to take away from this is around 1/4 of frauds appear to be detected in normal times. At least that's what's implied by the Andersen experiment. And then we can come to our overall estimate. Again, take this 4% number, which is the frauds that we observe in the overall population at any point in time, multiply that times effectively this 4 number, we come up with 15%. Or roughly 1 in 7 firms have an ongoing fraud at any one point in time. We do a bunch of sensitivity analysis in the paper, and we could do more that says, well, okay, this would be less if we used some other estimates, but we think of this as a baseline number of around 15% is what we take away from the Andersen experiment. If we're going to be quite conservative, we can come up with a number of around 7.6%, which still should be enough to grab, I think, your attention. We think that's a really cool experiment that we used, I must say. It isn't actually what we started. We actually started with this in our earlier paper. We'd run these regressions, and we had the idea that we would just sort of infer from these previous regressions what the underlying, and then we came up with the idea of the Andersen later. So this other idea is, think about running a regression, and we know under certain circumstances some fraud detectors are more likely, have a stronger incentive to bring frauds to light. Like I mentioned before, analysts. Firms with lots of analysts have an incentive to detect frauds, and therefore in those circumstances there'd be less frauds that would come to light. And so what we essentially want to do is run a probit regression on, and I'll just sort of here, the likelihood of a fraud being caught is a function of the number of analysts, whether there's media, whether it's easy to short the company, whether it's in an industry where there's a key TAM industry, which means there's a whistleblower bounty for bringing a fraud to light, and whether it's post-SOX, there seem to be more frauds detected. So in those circumstances, there was more likely that we were able to see frauds being detected, and so we wanted to run this sort of synthetic experiment of if all those were on high, what would be the fraud likelihood? How would that change? And doing this in a probit setting, we suggest 18% of firms have an ongoing fraud, quite similar to our earlier estimate. Of course, you're going to say, well, there's a problem with running a probit here, is if we have more analysts, that's not only going to affect the likelihood of detection, it's going to affect the likelihood of engaging in fraud. So for example, with more analysts, more frauds will be detected, and there's going to be less of a likelihood of starting in the first place. So you really want to take into account both of those. If there's a higher level of one of these, it's going to affect both the likelihood of engaging and detecting fraud. And so one way of dealing with that problem, it's not something that we introduced, it was used by Wang in an earlier paper, is using what's called the Poirier partial observability bivariate probit. It's getting the same idea as the probit that we took a look at here, but you want to have a separate regression for the likelihood of starting a fraud and the likelihood of catching a fraud, and you have to have a bunch of other covariates that are in one equation but are not in the other for this to be able to be correctly specified. What you see here, for example, is if there's a high number of analysts, it reduces the likelihood of starting a fraud, and it increases the likelihood of a fraud being caught. So this is a way of capturing this. It comes up with, at the end of the day, a number around 19% of frauds starting rather than 18%. So what we conclude using, it's just to sum up where I've come so far, what we're after is the iceberg. We're trying to figure out if there's a shock to detection likelihood, how many additional frauds are going to be revealed. The Anderson experiment suggests a quite high number. It's about between 2 and 4 times as many frauds are revealed. When we take a look at our data using this Poirier partial observability approach, it's a number of around 18 to 19%. So we're going to say, okay, we're going to stick with this estimate of 15% based on the AA experiment. Is that a big number? Yeah, we think it is. Is it an important number? Well, it depends how costly are the frauds. And here we have to address how costly are detected frauds and how costly are the non-detected frauds. Because non-detected frauds may not be as costly as the detected frauds, right? We have to kind of address that problem. So I think our main contribution to the paper comes out in taking a look at this iceberg, but we also have to address this question of the cost of fraud. And here, there are others that have taken a look at the cost of fraud very carefully, and I have to sort of bow to my discussant who's done most of the work in this area, and we rely heavily on that work. And one of the important ideas there, if you're taking a look at cost, you really want to get the sense of the cost of fraud, the reputational cost, rather than the cost. For example, if you inflate the books and you say we have sales that we don't have, and the firm goes up, and then all of a sudden you reveal, well, those sales were fictional, well, the price is going to come down. Well, that's a fundamental. That's not a cost of fraud in the long-term sense. The cost of fraud that we are interested in is the cost of fraud over and above this misstating of the fundamentals. And just to get a sense, that can be a real significant thing, because if you lose trust with your suppliers and your buyers and your employees and your customers, it may be very difficult to contract, and there could be significant reputational costs. And some work that Jonathan has done with co-authors has come up with some nice estimates of exactly that, taking a look at taking out the fundamentals, getting at the reputation costs of a number of around 22% of enterprise value is lost associated with fraud. We're going to do a bunch of other things in a different way of coming up with this, and it's about the same number in the end of the day. So if you don't like our estimates, you can stick with Jonathan's because they end up being around the same number. We do this a different technique because we want to take a look in our sample what the costs are fraud rather than relying on this previous work. And so let me just sort of quickly, how much time do I have? I got 5 minutes. Okay, so what we do is a relatively simple idea. We want to start, we basically want to know what would the firm have been worth absent the fraud. So we start off with a circumstance. We know its value. We know when the date of the fraud started from the security class actions. We say, okay, at that time, if the firm had done just as well as sort of the median firm in the industry, what would it have been worth at the time at the end of the fraud? And then we compare that with what the actual value that the market places on the firm once the fraud has been revealed. The difference between those two numbers should capture the cost of the fraud that's not related to the financials. For example, the sales example, you inflate the sales, the price goes way up, the sales are revealed to be fraudulent, the price comes down. We're comparing, then we're looking at the sales at the end, the true sales, and we're seeing what market value they place on that relative to other firms in the industry, what they are worth. So that's the difference between those two. And so that's what we're going to try to do to back out what the cost of fraud is. And we use we aren't sure whether we should use an EBITDA multiple or a sales multiple or an assets multiple. We take a look across all of them, and we come up in our sample of detected frauds, the cost of fraud is around 33% of the enterprise value. That's an important, it's an important number. It's a large number here. And then we want to take a look at the cost of all the frauds. So we've got the frauds that are detected. What is the costs of the non-detected frauds? So here, a nice thing we can do is it could be that the frauds that aren't normally detected, that maybe they're just not that important. They're kind of, not relevant frauds. So this is where the Anderson experiment is really nice too, because the Anderson experiment, those new frauds that are brought to light in the Anderson experiment, we know which ones those are. Well, let's compare how costly they are compared to the population. It's not the non-detected frauds, but it's the normally non-detected frauds. At least we can compare them relative to normal frauds. So these normally non-detected frauds that we take a look at here, we find out with them, the cost of fraud is around 19%. It's less than the 33%, substantially less, but it's still sizable. And so when we take a look at the overall cost of fraud that we observe in our sample, we use for the non-detected frauds this number. Now you can quibble with this. You could say, well, maybe it's actually zero. Right? The non-detected frauds, you're saying these are still detected, they're just wouldn't normally have been detected, and that's fair enough, right? So we show some sensitivity analysis to alternative assumptions about what those costs of those frauds are. We try to address this, and we try to be clear about what we're trying to do. So at the end of the day, if the cost of fraud is about 20% of enterprise value, that's a larger cost for the detected frauds, a smaller cost for the normally non-detected frauds, but 20% of enterprise value, and about 15% of firms have an ongoing fraud at any point in time, then it would say that the expected cost of fraud is just the product of those two numbers, or about 3% of enterprise value. That's a big number. Right? You just have to take a look at firms with $750 million in assets. What's the value that they have here? Taking into account the fraud duration, we come up with a really large number. So that's what we kind of come up with. So now, you can kind of go back to the cost-benefit analysis of any kind of regulatory instrument that you're taking a look at. Is SOX justified? There have been lots of papers that have showed that there's a significant cost associated with SOX introduction, Section 404, the internal controls, all this sort of extra effort associated with that. And what we kind of come to the conclusion is, as long as SOX reduces the likelihood of fraud by 2%, just 2% reduction in the likelihood of engaging fraud, it's worthwhile. That's what our numbers kind of lead us to believe. Or if you want to take a look at forced auditor rotation, which is a big active discussion in many circles. Lots of costs associated with forced auditor rotation, but if we infer that forced auditor rotation is actually valuable, if it can reduce at all the likelihood, and this Anderson experiment would suggest it does have some salutary benefit, we come up with another positive number. So let me just sort of conclude. My time is up. What I want you to take away from this is a couple sort of, we think it's important to take a look at the iceberg. When we take a look at the iceberg, we come up with a number of the iceberg being either equal in size to the detected tip or up to 4 times the size if we believe our Anderson experiment. And under those circumstances, about 1 in 7 firms have an ongoing fraud taking place. That fraud is costly. You could take a look at Jonathan's earlier estimates. You could take a look at our estimates. It's a big number. And therefore, cost-benefits analysis, which suggests things like SOX and auditor rotations. And when I talk to my board members of a couple of corporations, it's worth spending some time and attention to see if you can reduce the likelihood of fraud starting. That's it. That's all I have to do. Thank you very much.